And here, okay, this is the screen that will give you different options of searching. Explore gives you all of these research topic. That's your keyword search, the author search, company name, all of these items you can do in the explore field, okay, on the explore tab. Then these substances, you're going to be using chemical structure, molecular formula. A property you won't need to use, but it's in case, you are asked to find a solvent for something and you know some of the properties that you need to use a solvent. That's where you will use this because it gives you the properties of solvents and reactants and how they work together. It's not something that you're going to be using this year, I think. And then this is substance identifier. What are substance identifiers? Substance identifiers are the chemical abstract. Let me click on that. These are all your substance identifiers. That is the name, the trade name, and then the chemical abstract number, which each chemical has a specific number, and some of them they have multiple numbers. So this is another number. If that element or that compound is in the pure form, it's not synthetically made, then it has a separate number. In the natural form, if it is there, then it has a different abstract number than the one that's made in the lab, which is a synthetically made substance with similar properties, okay? So that's why you'll have, sometimes you will see different numbers for your product that you're looking for, and that's the reason why. Then I'm going to start first with research topic. This is the one you're going to be using the most. And in this, hold on, maybe I got an email. Okay, no. So then I'm going to, first page itself, you have to click advanced search. This will let you say, I want only journals, because we are going to look at journal literature here. We're not going to look at any of these others. We are not interested. And we're interested, at least I am, only in English. If you're fluent in other languages, you can keep it that way. And then if you want to do an author search, you can do here, but I don't want to do an author search, and then I'll give you a reason why later. And if you know, if you have somebody you want to find out where that person is or wherever, you can put a company name and see, and put the author and see where that person is. But we can do it a different way. Here, this is what I'm going to be doing. And just to give you an example, suppose you want to know since you're going to be doing the search on Flint water crisis, you can start here. I'll teach you how to use Flint water crisis. You just type it the way you are speaking, natural language, okay? And see what happens. Okay? And this is what it will bring up. There are 67 of them, right? So I'm going to look at these and say get references. And here are what you have to go through. This is not what I want, because it's in Quincy. I don't want Quincy, I want only Flint. So I'm going to Flint, Michigan water system recovery. Now this is what is happening now. It all happened because of corrosion of the pipes. Lead got into the water and caused lead poisoning in the population, right? So another term for Flint water crisis, or you can look here, click on it, and it will show you the keywords that it's been using, okay? You can look at those, or you can look at the full text here, and you can also look for get related citations. That means get cited and get cited or citing or cited. What do I mean by that? This article that was written somewhere maybe last year or so, it was in 2020, this year it came out. If somebody has used this article and written up another report or whatever, then that becomes a cited article, okay? So from one article that you like, you can expand your search by getting cited and citing. Citing is the references at the end of the paper that you saw, that you can see. These are all the citations that this has. And you can look at those too, just to see if anything is of interest to you. This is normally how you do your research, right? You do the cited and the citing and look up information. So here is one. And then if you want to get the full text, you say link to other sources, retrieve the full text. And if we have the journal, it will open up. You can say SFX check this or look at this one. I'm going to look at GSU if we have it. If we don't have it, then you can get it on interlibrary loan at GSU. They don't have it, okay? And then look at more options. And then you can go to GSU interlibrary loan and click go, and then it will come to you as a PDF file, okay? The other thing that I was going to also mention is that if you go DOI, sometimes, you know, somebody has put it up on the server somewhere, and this is where it is. So if you can find it, you can download this article and see if it's available to you. See, it is available, so you can look at it. So just because GSU doesn't have it, don't have the impression that you cannot find it somewhere else. And this is how you're going to find out where it is available, okay? You can save this and keep it on your folder and use it later. So now I'm going to do another search, which I think is important for us to learn. The one that I'm going to talk about is, once I did that, I'm going back to my first page. And when I put in Flint water, what other terms could I use, right? So I can put Flint water crisis. And then instead of an or, which you usually use in other searches, which is like a related term or a synonym, here comma is the or symbol. So you just put a comma there after crisis, and then you do lead poisoning, which is another term for what happened in lead poisoning in drinking water, right? And then you do your search. And you, whatever you get, you can also limit it by publication years, but right now it's pretty recent. It's in the last 5 years, so we don't have to do that. So I'm just going to do searching. And this, I got exactly what I want, because this is 16 references, which are more precise than what I got before with just Flint water crisis, because our main purpose is to look at the lead poisoning that happened. Usually for this assignment, what we do is there are only 4 of you, otherwise we would have broken you up and asked you to take one takes the like the measuring of lead poisoning. How does that happen? It's a chemical way of assessing what level of poison is in the water, right? And that is to do with Dr. Kent's course. What I deal with is how you find information on lead poisoning. And that's what my course is about. Then there's also one which is ethics, and which the impact of this lead poisoning has been horrible on the underprivileged or Black and poor populations in that area. So it's an environmental justice kind of thing. So that there are three subtopics that we usually give. But I haven't talked to Professor Kent yet, but then we'll come up with a decision as to what you need to look at. But start practicing how you're going to find information right now, okay? And these are the ones that I'm going to look at. And this is like how there can be genetic diseases afterwards, because it says embryonic stem cells, is this talking about. Then I forgot to mention that once you get something like this, you can analyze, and you can do it by author, or you can do by registry number and database. That is because this database consists two components, Medline and CA+. Now, CA+ will be the one, the chemical abstracts. You can look at this for our purposes of finding the methods to test for lead in drinking water, okay? Or if it's Medline, you also want to know what are the health effects of lead in water. So that's where you will go for and limit it to just the Medline. And you'll get 13 of them here that you were going to look at, okay? And that's the advantage. You don't have to go to another database to look for the health impacts of lead poisoning here. It's all in one place, okay? Then suppose I want to refine. Once you get a set like this, there are 16 references in this set. You want to make them smaller and more manageable and see if you can be a little more precise. And that's why you will do by author, document type. I can do journals, right? Which I did before too. So I can just say again, refine. And that's how you start getting smaller and smaller number of records that are manageable for you. And here is also another one that you could do. Publication year, language, we already did only English, so you don't have to worry about. If you know a person who's working on this, then you could do it. University of Michigan, I'm sure, is doing a lot of research on this. You can put University of Michigan if need be, okay? I'm pointing these out because these are the questions that are on your assessments. When will you be using company information and all of that, okay? And then you can categorize. Now, what does categorize do? Now here, I'm going to look at substances. And then in drinking waters, I could use that. And then I can see, these are the different aspects of it. I can look at health hazard. I can look at iron. There was iron, there's lead. And then say, okay, what do I get? I get only those which have led during the Flint water crisis on mouse. That's the same one we got, but you got a fewer, 12. So 3 were eliminated. This is a smaller set. It's not a big deal, but sometimes if you get about, like earlier we got 60, we could have done something like this and managed the set, filtered using these filters and got more precise information. Okay, now I told you we could look at chat, but right now I cannot see my chat. So I don't know if you have any questions, but wait till the end and then I can answer your questions if you have. So then this is one way of looking at information, right? And what are the other ways? I'm going to go back. I'm going to look at explore, and then I'm going to look at substances. No, author name is what I had to talk about. Now, why am I asking you to do this? Because in all these databases, you have a problem with author names because they have variant spellings. I'm going to give you an example of Ran Mahoti. You know him. He's in the division. And you will see how many ways his name is spelled. This is all the spellings for him. Now, how do you know which is him and which is not him, right? So I'm going to look at all of these and this and say, let me look at them. And this is what you're supposed to do. The question I have for you is, Dr. Soa, and see how many publications he has, because his is a very unique name too. I don't want to tell you the answers, but if you are a little bit confused or whatever about his middle name, ask him. He will tell you what his middle name is. And he knows that I have put his name on this assignment, okay? So these are, now this is 22. This is the most common way that maybe his name is spelled. But if you look at it, this is him, right? With just Ranmahote Kuluga Mana, and the others are, if I looked at this one, this is not him, because you know how I know that? I'm going to look at this one and I'll show you how to look at it. See, it tells you company organization. This is, I know he hasn't been in that University of Michigan, So this couldn't be him unless he collaborated with this institution. So this doesn't seem to be like him. So I'm not going to take it. And then as you become more familiar with people's research work, you will know what they do mostly, and so this one is totally different from what he's doing. So I don't think this is him, okay? So I'm not going to use this one. The second one that I'm going to use is this. I know he's this because if I look at here, it gives his name. Oh, I got the same one. Sorry, not this one. There's another one, the next one. This one. If I look at him, that's him. Because it says Division of Chemistry and Biological Science, Governor State University. So I know that is him. Now, if I want to limit it by company name and do Governor State University, I can get all of his work when he was at Governor State University. You can't get all of his work because he had a workplace prior to coming to GSU. So that means you're limiting to only current work, not past work. And a lot of times you have to look at the whole span of the research to come to some kind of a knowledge of what his work entails. Okay, this is how you are going to be doing a author search. And I wanted to give everything, like this were 47, and how you eliminated the ones that you did not think were him. Okay, don't just give me this is him, 22. That is not what I'm looking for, because most of these here, the 7 one may be him because it says Sanjaya, that's his first name. So it could be 22 plus 7, 29. And you don't know how the name has been spelled in the database. So you have to go step by step. So next I'm going to go to I'm going to substances, right? Chemical structure. This is one of the most important things you're going to be learning how to do in this course. I'm not going to go into detail here. I want you to do something which is go to SciFinder help. Look at it, okay? Again, it might ask you to log in. Once you do that, these are the sources you can do. Introduction to SciFinder, the tutorials that are available, is that what you're going to be looking at. Introduction, basically what I'm telling you now, but it's a video that you can watch, the short videos for author searches, subject searches, and stuff like that. But basically what I'm just telling you. The second one is searching this exact structure. These are the ones that you have to pay attention to for the next week's assignment. And this is drawing and all of that. Don't have to worry about this part, but draw structures and draw reactions. Reactions, you don't have to worry because I'm not giving you reactions. I'm just going to give you draw structures. But if you're interested, you can ask Dr. Sova to help you with reactions if you need to find information about it, okay? That is the way to do this, but I haven't included it in your readings about reaction structure searching, so I don't want to ask you questions about it, okay? Then once you have done with these videos, then you'll be a little better able to answer the questions on structure searching that I have told you about, okay? Then let me do one search for molecular formula, okay? Like, let me take this one, H2SO4, and see what I get, okay? And here is this. It tells me sulfuric acid, you know that. And like I told you, this is the chemical abstract number, which has a unique identity. You can look at it and it will give you all the properties, additional details, everything. Sources of, it's loading. I can expand the search if I want by taking this and then, you know, sometimes students just copy and paste it on the structured drawing. I don't want you to do that. I want you to learn how to draw a structure. It's a little tough to start with, but as you gain more confidence, it'll be something that you will remember for the rest of your life. So start doing it the right way. Don't make cut and paste. You can do that. Sometimes even in SciFinder, they tell you, find the structure and then copy and import it into the system. That's fine too if you're doing a very elaborate search, which has the structure is like very complicated, then you don't want to stay there drawing each time. So you can just import it in. The other place I want you to go is something called CHEM3099. This is a database by the Royal Society of Chemistry, which is from England, right? Now, if you go here, they tell you systematic names, synonyms, trade names, registry numbers, miles, and INCHI or CSID. Now, what is this, right? The way you can depict a structure of the chemical, you can do it by drawing the structure is one way, or they have a different notation for giving the structure, and that is called smiles, or it can be INCHI, or this one. I mean, I don't know if you had it in your class, if Dr. Aran Mohati taught it to you, but that is something you would have learned there. If not, it's not important. We don't use it that much. But I'm just telling you as an information that you can use these as substance identifiers, okay? I'll give you an example here. If you were to look at aspirin, say, it gives me the formula, and then it also gives me the synonyms for it, and also gives me more details if I do. See, this gives me, this is the structure of aspirin in this system. So this is something that you can copy and then use it in there. And here is something else. When you see this is a 2D version, right? You can see it, it's in one plane, but not all these chemicals or elements are in one plane, they're in different planes. And so if you look at the 3D version, you will see a better, if it is there for this one, more if you see this is 3D version should have come up, but I don't know why. There it is. See, it shows the different planes that, and you can turn it around. You can see it's not in one plane, right? It's in different plane. And that's the reason why there are these structure notations that are important to understand. And I will send you a paper that will explain what this is, what the structure signifies, how you can understand the structure of a substance by looking at how it is drawn in different planes. That is important. And you're also knowing about the stereochemistry of certain, especially drugs, they are stereo isomers, or, you have to look it up and see how each of these isomers reacts. You can't be um, positive that both the isomers are good for health. They are not. There are some drugs which has more is more very toxic to the system, and they found it the hard way. I will, when we talk about the structure searching, I might have another session like this if need be, and then we can see how things are different in stereoisomers. Okay, but I think this is the basic of searching in SciFinder. And if there are any other questions, you're free to ask me as an email or as I prefer text because I always see my text immediately. If you send it to my GSU email, I may not see it the same day. I don't look at it that often. That's why I'm giving you my cell phone number. Okay. Let's go to this SciFinder. And I've asked you sometimes, right? If you look at this one, what does it gives? It gives you reference, CAS reference roles, whether it's how is it used? That's what you're going to be looking. Additional details, you're going to be looking, document type, and all of this. And in certain cases, in this additional details, you get EPA information, whether it's a controlled substance or whether it is available anywhere. And a lot of times it also tells you where you can buy it. And if you're working in a lab and you have to buy the chemicals and start your experiments, or you need to order them for your particular experiment, this is where it comes in handy to find out where you can get that substance. That's one thing. And then also data sometimes is available, like how you can get the properties, like physical properties, some of the chemical properties, and also I think you can get the IFR and all those structural details you can get with it. You can see the peaks and everything and decide what that substance can be identified by. So these are some of the things that we can do. I don't want you to go getting overwhelmed with the information. So I'm going to stop now. If you have questions, ask now, because we have only 4 minutes left and it will die in 4 minutes. So let me get out of the stop sharing. And if you have any questions, ask me now. I'm sure I felt I was rambling, but I hope you got something out of it. If not, ask me the questions now.
No, I pretty much understand it. That was a real good explanation. I appreciate it.
So if you have no questions, I think that in all my experience of teaching this course for the last 10 years, I find students find it very difficult to understand what SciFinder does. And I don't like them going to Google and finding the information and putting it there. But I just feel maybe I didn't explain it enough, so they didn't understand. So I grade very leniently, but I feel bad that they're not learning. So that's the reason why I think it's important for you to understand what you're doing in SciFinder and why it is important for you to learn it. Okay. Um, I hope that this has been, helpful. And if you have any questions, especially you are not doing the structure searches this week, you're going to do them next week. So I'm going to give you more time for this to maybe middle of next week till maybe Thursday instead of Sunday. Um,
Okay, that would be really
yeah,
helpful.
it'll give you more time to do it, but I don't know. I have recorded this, so if you want, I can send you the link to the recording, so that it's kind of
Yeah,
a
that would
little
be
um, refresher for you to understand later. And then I'll put it on the course guide so that everybody gets to see it, because a lot, 3 more students didn't show up, and it's really hard to go on explaining to each student how to do a search in this. That's why I wanted all 4 of you to come and learn how to do the search. But since it's not possible, I'm going to stop now, and then by the time the the recording comes,